So for my digital clock project, the components I used were 6 common cathode 7-segment displays, 6 CD4026 integrated circuits, 1 CD4060 integrated circuit, 1 SN7476 integrated circuit, 1 SN7411 integrated circuit, 2 push buttons, 42 220 ohm resistors, 2 10k ohm resistors, 1 2.2k ohm resistor, 1 1 mega ohm resistor, 2 diodes that are 1N4007, 1 100 nanofarad ceramic capacitor, 1 33 picofarad ceramic capacitor, 1 5 to 45 picofarad trimmer capacitor, 1 32.768 kilohertz crystal, 3 breadboards, and 22 AWG solid core wire. So this digital clock can be explained in 3 steps. The first one is that I needed to snap 3 breadboards together and then connect all the power rails to each other using jumper wires. This made sure that the whole board was powered using just one power supply. The second step was to add the 7-segment displays and resistors. For this clock, I used 6 7-segment common cathode displays. I connected the cathode to the top power bar using some small jumper wires, as you can see. If I directly connected the segments to the 4026 integrated circuit, the LEDs would die, so I needed to connect a resistor to each segment. I added the resistors as seen in the video, while making sure that none of the leads would touch. The next step was to add all 6 CD4026 integrated circuits. The CD4026 IC is a counter with a 7-segment decoder that will address the display. Each 4026 can drive only one display, so to display the number 10, I needed to connect the carry-out pin of the 1s to the clock pin of the 10s. The next step was to make the clock signal, so in order to make the 1 Hz oscillation, I used the 32.768 kHz crystal and halved it by 15. An easy way to halve the signal was to use a binary counter like the 4060 integrated circuit. This IC will half it 14 times, so the output will be 2 Hz. To half it one more time, I used the integrated circuit 7476. If I wanted to adjust the frequency, I would have had to adjust the trimmer capacitor using a tiny screwdriver. The next step was to add the 7411 IC in order to reset the seconds and minutes when they hit 60 seconds or minutes and the hours when they hit 24. The 7411 IC is a triple 3-input AND gate. This means that the output only turns high when the 3 inputs are also high. For the minutes and the seconds, I connected the E, F, and G segments from the 10s as inputs and outputs as the reset for the 10s. For the hours, I connected the F and G segments from the 1s and the G segments from the 10s as inputs and outputs as reset for the 1s and the 10s. This enabled the hours to reset as soon as it hit 24, and the seconds and the minutes to reset as soon as they hit 60. Since the clock pin floats when the button isn't pressed, I needed to add the 10 kilo ohm pull-down resistor. Finally, the last step was to connect the 5-volt power supply and see the circuit work its magic.